All right. So, ladies and gentlemen, here we go. We are working on polyatomic ions. So we're going to get into some naming stuff. But before we do, we need to talk about this idea of a polyatomic ion. So this is a group of covalently bonded atoms that have an overall charge. So as you see here, you got NH4, OH minus 1. All of these are covalently bonded, but they're done in a way that actually makes them have an overall net charge. So for example, we looked at NH3. Right, you add another hydrogen in there, that makes up a +1 charge. When you have OH, it's a -1 charge. When you have NO3, it has a -1 charge. So basically you have either less than or more than what your normal number of electrons would be within that compound that makes up an overall charge. Now these are 6 that I want you to memorize. So sometime you should go ahead and make a set of flashcards for these so that you know both the symbol and the name, the formula and the name. And I just wanted to introduce you to these guys on this slide, and then you will need to be able to write compounds with them, but that comes on the next slide. So when you're writing formulas with polyatomic ions, basically the charge needs to be neutral within any compound. And when you're writing formulas using polyatomic ions, it's no different than when you are using monatomic ions. And so when an Mg+2 and a CO3 -2 are going to combine, it's going to be in a 1-to-1 ratio because the +2 and the -2 cancel each other out. Right? So in this case, my charge is balanced. So it only takes one of each. So we would just write that MgCO3, and this would be called magnesium carbonate. Now, what if I have something where the charges don't balance when I have just one of each? Well, we looked at this a couple different ways. We talked about it with charge, and we talked about it with valence electrons. It's a little tougher to look at valence electrons when you have polyatomic ions, so we're just going to use the charge. +2 and -1, those don't balance out, those don't cancel out, so it takes 2 of the NO3 -1s to balance out the charge of the Mg+2, and your formula ends up being Ng NO3 in parentheses with a 2 because it takes 2 of these NO3s. If I didn't have the parenthesis there, it would look like NO32. And that's not what we have. We have 1 Mg and 2 NO3s. Right? So if I had a particle model, if I was drawing a structure for this, it would be an Mg and then an NO3 coming off in one direction and an NO3 coming off in another direction. It's just showing this ratio within the compound. So what I want you to do, grab a piece of paper. It's nothing you're going to turn in, but you are going to have me check this, and you are going to get credit for doing this. It is going to be an assignment in the grade book that you will get checked off when you show me your answers for these 5 compounds that are formed. So Ca+2 and OH -1, +1 -2, +3 -2, and so forth. So remember that for all of the polyatomic ions, OH, NH4, SO4, PO4, NO3, if you have to have more than one of them, put them in parentheses.